This video is about normal distribution.
Okay, a very good morning. We are going to continue the normal distributions. Okay, this is the formula for normal distribution. Probability of Z equal, we got the mean mu or expected number mu, standard deviation, okay, sigma, okay, x minus mu divided by sigma. Okay, it's the most widely used model for the distribution of random variable is a normal distribution. Okay, has a curve with bell shape, sometimes called as a Gauss distribution. Is frequently applied in finding the probability of certain range for continuous measurement such as height, weight, and times. If binomial Poisson are the discrete random variable, Poisson distribution come from the continuous random variable, for example, the height, weight, and time. And this is a formula for normal distribution. Which is a continuous random variable, is said to be normally distributed with mean mu and variance sigma squared if its probability density function is equal to fx. Then where the fx is actually equal to the integral of 1 divided by sigma divided by square root 2 pi times exponent negative the bracket x minus mu squared divided by 2 sigma squared. The fx is not the same as probability of x. The px would be 0 for every x because the normal distribution is continuous. However, for probability of x in the interval x1 to x2, it is equal to the integral of fx dx from negative infinity to positive infinity. How to use a standard normal distribution table and also using your scientific calculator. For example, you want to find probability of z greater than 1.37. Then you go to your normal distribution table. Find the normal distribution table. Z greater than 1.37. Normal distribution. Mean the area is 1.37. So you find the probability z greater than 1.37. So you want to find the area probability of z greater than 1.37. This is not area here. This value 1.37 is actually point to here. Mean this point. Yeah. This point. The probability is actually given by the area below the curve of fx. So now we want to find the probability z greater than 1.37. Mean if this is a z, so this is z, so the z value 1.37, and what is the area there, the shaded area. So in your normal distribution table, you find 1.3 and then 7. So the area will be 0.08534. First of all, show you the normal distribution tables. In your normal distribution table, this is actually the alpha, and we want to find probability of z greater than 1.37. So mean alpha is here, the z here. Alpha is equal 1.37. So we find 1.37. Look at this is a normal distribution table. So 1.3 and then look up 7, 1.37. Point. Look at the here 1.3 and then find 0.07. The value mean this is the area 0.0853. You get the value 0.0853. Okay, if you want to use your scientific calculator, find probability of Z greater than 1.37 normal. So under the distribution menu or mode, you get the normal greater, this one greater, so you should use normal CD, number 2. Okay, so greater than 1.37 mean lower value is 1.37. Okay, upper, okay, so upper will be up to a very big number. Let's say I put 9 times 10 to the power of, or the power of 99. Okay, sigma, okay, since this is Z is a normal distribution, okay, the sigma will be 1, the mean will be 0. So you get 0.0853. Okay, if you use your normal distribution table, 1 point, that's now 97, am I right? 1.37. Here 1.3, okay, and then 7, 0.0853. So it's tally with your scientific calculator. Mean the alpha, okay, here column. First of all, look at column 1, get 1.3, and then get the column 0.007. This is the area. Okay, the area for probability of Z greater than 1.37. In scientific calculator, okay, mean here lower bound is 1.37, upper bound is very big number. I put, let's say, 9 times 10 to the power of 99. Okay, for normal distribution, okay, the standard deviation is 1, mean is 0. Okay, and then B, if you want to find actually K. Find K. When? The question is actually find the value of K, or find the K when probability of Z greater than K equal to 0.0268. Okay, the statistical Poisson and binomial distribution table is given the area for greater and equal. So you read from the table the value 0.0268 and then refer here. This is the alpha 1.9, this is 0.003, so will be 1.93. 0.0268. Okay, find the area value inside the table 0.0628. 0.02, am I right? 0.0268. 0.0268 here. Okay. This value, 0.0268. So 1.93. So it's 1.93. So K is actually 1.93. Okay, if you want to use your scientific calculator, what's the value of K when such that the probability of Z greater than K, you get the area 0.0268. Probability is actually the area below the curve of the fx. Okay, so again, go down, distributions, normal CD. Okay, but remember, scientific calculator give the area, okay, is less than and equal. So mean, okay, the right hand side area is 0.0268, the left hand side area will be 1 minus 0.0268, will be 0.9732, and this is actually equal to the probability of Z less than or equal to K. Remember, scientific calculator give the left hand side area, but the statistical table give the area at the right hand side. So I choose Okay, and then this one is actually inverse normal because you want to find back, okay, the value of k. So inverse normal, so you choose number 3. The area is 0.9732. Okay, sigma is 1, which is correct. Mu is 0 because it's a normal distribution. So I get the answer, hold on. Okay, I think got something wrong. 0.0268. Hold on. Repeat one more time. Inverse point. Sorry, the area is here. Area 0.9732. 0.9732. Okay, sigma is 1, mu is 0. Correct. Then we get the answer, okay, 1.9301, correct. Is correct. So mean question B, find k when probability of z greater than k. So if we use normal distribution table, look at the value 0.0268 and then read here 1.9, so the answer is 1.93. If we use scientific calculator, will be, okay, the inverse normal in here, go down, number 3, inverse normal, area, okay, the area, because the scientific calculator, okay, give is actually calculated based on the left hand side area. Okay, so you want to find this k value, the area being given 0.0268 is the right hand side area. So the left hand side area, since the probability add up is 1, so the left hand side area is 1 minus 0.0268, so we get 0.9732. So you key in the area 0.9732, sigma is 1, mu is 1, you get k. So the k is 1.9301. Okay. Okay, and then the next one, by using the normal distribution table, find the value of probability z greater 3.15. Z greater 3.15. Okay. So we go back to here, number 3. Okay, the normal CD, normal CD 2. Okay, when greater means left, okay, minimum is 3.15 up to infinity. So minimum value will be, okay, I'll put up here, easy for you to check the answer. Yeah, see, 3.15, so minimum value is 3.15. 3.15. Class week, you can see all lower, upper, okay, and then sigma, mu will be next screen. Okay, upper, okay, correct there. Mean is 1, standard deviation is 1, mean is 0. Get here, 0.008. So since we are in the greater, I will find back D first, greater than negative 1.54. So mean lower is negative 1.54. Okay, upper will be up to a very big number. So I just change here, I do the equation D first. For the greater, minimum is negative 1.54. Okay, upper, same thing. Mean, standard deviation, mean same. I get here, equation D, 0.9382. Okay, check whether I still got the greater one. Okay, H, that's now I have done. Here, A, D. I will do all the greater since are in the greater. Okay, greater. For greater, this is lower value, lower value. Okay, upper, put a big number, big number. So, okay, H, now I'm going to do H. Okay, H, probability of magnitude Z greater than 1.35 is actually mean magnitude z equal to 1.35 mean you got negative 1.35 up to positive 1.35. Okay, so greater mean, okay, the area there, greater mean, okay, and normal distribution, they are actually at a mean zero, so they are actually symmetric. So magnitude z greater than 1.35, you got left, okay, left area, right area, or equivalence to the 2 times probability of z greater than 1.35. Z greater than 1.35, then I will still in the greater mode. So my lower is 1.35. Okay, upper is still a big number. Okay, sigma mu same for normal distribution. Sigma is 1, mu is 0. Then you get 0.0885. So 2 times this value. Okay, 2 times this value. Okay, and then if you go back 1, 2 times answer, get 0.1770. Okay, so okay, and then I will go back to do B and C. B and C. So menu, find distribution, CD, Z less than 2.85, less than 2.85. So mean less than 2.85. So mean your distribution, let's say 2.85 here in left side. Okay, so mean minimum will be the very small number, maximum will be 2.85. Okay, so minimum, let's say I put small number negative 9 times 10 to the power of 99. Okay, maximum will be 2.85. 2.85. Sigma 1, mu 0. You get 0.9978. So this done. So C, same thing. Okay, lower will be a small number. Okay, again, lower is a small number. Maximum up to negative 2.22. Okay, 2.2. Sigma 1, mu 0, you get 0.0139. Done. Okay, E, so okay, in the interval, so this is lower bound, this upper bound. Easy. You just input everything there. For question E, the lower bound 1.72. Yeah, this is a lower bound, upper bound 2.76. Sigma 1, mu 0. So we get 0.0398. Done. Question F. Okay, lower is negative 1.72, upper is here. Okay, lower is negative 1.72. Okay, upper 2.3. 2.3. Sigma 1, mu 0. You get 0.9466. Done. Okay, G. So lower is negative 1.89, upper is negative 0.24. Okay, lower now negative 1.89. Okay, upper negative 0.24. Sigma 1, mu 0. So 0.3758. Done. Okay, I. Okay, probability of magnitude Z less than 1.91. Less than 1.91. So mean the interval. Okay, if greater, left side, right side. Okay, if less than 1.91, so mean in between negative 1.91 up to 1.91. Okay, then lower is negative 1.91. Okay, upper part 1.91. Sigma 1, mu 0, 0.9439. So same thing for the second example. Same thing for the second example. You can calculate, and this is the answer. Okay, probability of z greater, so mean this will be minimum. Upper bound is a very big number, but okay. So lower will be question A. Focus on question A. Lower is 0.75. Upper big number up to 9 times 10 to the power of 99. Sigma 1 mu 0. 0.2266. Okay, we find the greater. So do question D. Question D. Lower negative 1.43. Upper same. Sigma same. Mu same. So 0.9236. Okay, see where. Okay. Probability magnitude z greater than 1.23 equal to 2 times probability of z greater than 1.23. Okay. So lower 1.23, upper big number, sigma 1 mu 0, you get, okay, 2 times 0.1093. Okay, and then you mod 1, 2 time answer, so you get 0.2187. Okay, done. Okay, no more yang greater, so we do on the less than. So find back Monod distribution, normal CD. Okay, question B, less than 0.95. So mean maximum is upper part is 0.95, lower part will be very small number. Let's say negative 9 times 10 to the power of 99. Okay, and then upper part 0.95. 1 mu 0, so you get 0.8289. Done. B. And then C, less than negative, probability z less than negative 1.42. So this is the upper bound, lower bound is a small number, so negative 9 times 10 to the power 99. Upper bound, okay, is a negative 1.42. Sigma 1 mu 0. So you get 0.0778. Done. Okay, probability of modulus z less than 0.99. Okay, so mean this is in between. Remember, in between mean is equal to probability of, because magnitude less than negative 0.99 less than z less than 0.99. If greater, then with 2 times probability of z greater than 0.99. So F, G, H, I, okay, key in the lower bound, upper bound, okay, correspondingly. Okay, for example, F, okay, negative 0.99, okay, upper bound positive 99. Sigma 1 mu 0, you get 0.6778. G, lower bound 0.67, upper bound 1.34. Sigma 1 mu 0, you get 0.1613. Okay, and then H, lower is negative 1.74, upper is negative 0.75. Sigma 1 mu 0, you get 0.1857. Okay, the last one, okay, I, lower is negative 1.54, upper is 2.32. Sigma 1 mu 0, 0.9280. Okay, so you are very familiar how to calculate using the scientific calculator. Now, okay, we have the normal approximation to binomial distribution. Okay, the normal distribution can be used to approximate binomial probability for case in which n is large. Okay, such that the normal approximation should be used only when np greater than equal to 5 and nq greater than equal to 5. Because the binomial distribution is discrete and the normal distribution is continuous, then we must use the continuity correction, adding and subtracting 0.5. For example, to find the probability of 12 success, okay, 12 success, discrete, binomial is the continuous, then we should correct it become probability of x, okay, greater than 1.5 to 12.5. And this is a normal approximation to binomial distribution. To here, x equal to a, so okay, exactly a, so a minus 0.5, a plus 0.5, greater than equal to a, so a minus 0.5, greater a plus 0.5, less than or equal to a, and then you can refer to the table for all the cases. Mu, okay, for the normal distribution, okay, is n times p. Sigma sigma is actually, this is a binomial distribution, sigma is actually square root of npq, and the np greater than equal to 5, nq greater than equal to 5. The binomial distribution can be approximated using normal approximation. Okay, then there are 5 steps to use normal approximation to binomial distribution. Okay, first step, check whether the normal approximation can be used. Okay, must be used when n is very large, such that np greater than 5, nq greater than 5. Find the value of mean and standard deviation. Mean is n times p, standard deviation square root npq. Write the problem in probability notation using x. Okay, x, okay, follow the binomial distribution, x minus mu divided by sigma. Rewrite the problem by using the continuity correction factor and show the corresponding area under the normal distribution. Find the corresponding z value and solution. No more. Okay, stop for a while and find the example for this. Okay, find the probability that 200 tosses of a coin will result in between 80 and 120 heads inclusive. Be less than 90 heads. Okay, the solution: toss 200 times, n is actually 200, n is 200. Okay, probability of getting hit is p is 0.5, q is failure is 0.5. Then the expected number mu will be 200 times 0.5 is 100. Okay, standard deviation is a square root of npq. 200 times 0.5 times 0.5 is square root of 50. Okay, so this is actually first we can find using the binomial distribution, so which is probability of x, okay, inclusive 80 up to 120 inclusively. Then we can use k binomial cumulative distribution in your calculator, which is f120 deduct f79. Okay, because calculator give the area less than or equal, so we take the probability of x less than 120, cause inclusive 80, so we got the minus f79. Okay, so we go to your distribution 3 binomial CD, binomial CD number 1, then variable 100 x 120 n 200, p 0.5, so I get 0.9982. because this one, if classic calculator, you can this value you can store in A. Just press RCL, the negative button. but here it can only keep in the answer. And later on I need to minus with here F79. Okay, so again I will go back here. Now X is 79, and 200, P is 0.5, Q just P, yeah? So I get 0.0018. It can only keep answer for the ES plus. Class week, okay, then this value you press the RCL and then here this button. Then you call back alpha A. So press the alpha button and then here the negative sign button, then minus alpha here. Then but this one I can only I cannot keep in the distribution menu. I cannot keep into the variable ABCD because even though RCL, but how to get the value? No, it's not keep. So menu 1, I can only, let's say, jot down 0.9982. The rest I can minus the answer only 0.9964. Okay, if we use since n times p is 100, as we said, okay, when the binomial distribution np greater than or equal to 5 and nq greater than 5, then the binomial distribution can be approximated to normal, okay, approximation. And then for, let's say, probability of x, okay, a to b inclusively a and b, you should correct, if we use normal distribution, we should correct it to a, okay, probability of, okay, x greater than a minus 0.5 but less than b plus 0.5. Okay, hence for 80 inclusive 80, so this is a 80 minus 0.5, which is 79.5, and then 120 add up 0.5, 120.5. Okay, and then use the normal cumulative distribution. So we go back to distribution number 3. Okay, normal CD, which is option number 2. Lower is 79.5. Upper will be 120.5. Okay, sigma, okay, here sigma is square root 50. Because this is x, this is not z. If this is z, then sigma is 1, mu will be 0. But this is given the x. So the normal will be, the mu will be 100. So I get 0.9963. Differ only, okay, 0.001. Okay, you can see if you put, let's say, lower is 80, if you don't correct it, upper you put 120. Okay, the rest is same. See the answer 0.9953. Run a bit. So after you correct it, okay, the error will be reduced. Okay, and then we look at question B first. B, less than 80 mean probability of x less than 90, less than 90, which is F89, because not inclusive 90, yeah? So mean you will add up 0 until probability of x 0, 1, 2 until 89. So we go back to distributions using binomial cumulative CD, binomial CD, variable x is 89, n 200, p 0.5, okay, 0.0687 using binomial CD. Okay, if you're using, okay, since np greater than 5, npq also greater than 5, then this binomial distribution is approximated to normal distribution. Okay, and then for probability less than 90, here less than 90 is binomial distribution for x less than a. For normal distribution, you should correct it to probability of x a minus 0.5. So mean 90 minus 0.5 will be 89.5. Okay, then again go back to distributions 3. which is a normal CD2, we choose 89.5. Sorry. Sorry. Less than 89.5. So means upper bound is actually 89.5. Let's go up. So this is the wrong one. Okay, so again, lower is small value, negative 9 times 10 to the power of 99. The maximum is 89.5. So minimum is very small number. Let's say negative 9 times 10 to the power of 99. Upper is 89.5. Okay, sigma is actually, this is a square root 50. N is a mu, mean here 100. So you get 0.0688, differ also one last digit. Okay, if you're not corrected but you put this is 90, you see what happened. Okay, here if you put 90, the error should be you see, sigma the point. You see, if you're not corrected, you put 90, it becomes 0.0786, which is quite difference. Okay, and remember, okay, beginning we show the normal distribution. You got the formula like this. What is the usage of this formula? What is the usage of this formula? Okay. Oh, not this. I don't want this. I want to copy this formula. Okay, I do for this one enough. One number. Okay, what usage of this formula? Okay. Mean here I directly key in into the scientific calculator in terms of x. If you key in terms of x, then the mean is n times p. The sigma is the square root of npq. If you change the given x into z, then later on the mean will be 0, sigma will be 1. Okay, let's check using question B. Question B. Okay, so if I put up into, I will insert my Mac type. Okay, when I count my z, x, which is in this case 89.5, because we would like to correct it using normal distribution. X is 89.5. Mean is 100. Okay, mean is 100, and then divide by the standard deviation. Sigma is square root 50. Square root 50. This. And you calculate it. What is the value there? Go back to the normal calculation menu. 89.5 minus 100. Okay, z is square root 50. So mean this value, calculate negative, put it to decimal place, negative 1.4849. Negative 1.4849. Am I correct? If I calculate this thing, and then my z will be here, negative 1.4849. That means I'm going to calculate probability of z less than negative 1.4849. So mean probability of z less than negative 1.4849. 4849. Okay, then you can use your using the normal CD. Okay. this is less than, less than. Okay, go back to the distributions 3. Binomial, normal CD, normal CD, normal CD. So lower again is negative, lower bound negative 9 times 10 to the power of 99. Because less than, so mean maximum is here. Maximum is negative 1.4849. Okay, if we already convert Z, okay, convert the X into the Z, then now the sigma will be 1, mean will be 0. So again, you get 0.0688. I get 0.0688. 0.0688 using the binomial using the normal CD. So same thing for this. If you want to convert to Z, okay, but I think I would like to keep into X, no need. Then I no need to calculate the value of Z, because using your scientific calculator, okay, scientific calculator, I just key in this is my lower bound, upper bound, then this is my mean, my sigma square root 50, mean 100. Rather than I need to convert, okay, the X into Z. Then I need to calculate again 79.5 deduct 100 divide by square root 50. Mean 79.5 I need to convert to Z. Here this value I need to convert to Z. Then only I key into the normal CD with the mu equal to 1, mu equal to 0, sigma equal to 1. But I think using scientific calculator, you no need to convert it. You can straight away key in, okay, lower bound, upper bound. This is a mu, this is a sigma. Will be faster than you convert. Okay. So I conclude back the normal distribution is for the continuous random variable. Okay. You have the, okay, mean the X is a continuous random variable with the, okay, mean, mu, and the standard deviation sigma. Okay, and when the binomial distribution, okay, with the n thrice, P is a probability of success, Q is the probability of the failure. When the n times P, when the n is very big, n times P greater than 5 and n times Q greater than 5, binomial distribution can be approximated using normal distribution, okay, with some character given in the table here. Okay, and then to use, okay, your to get the probability of the binomial distribution, okay, it's very easy. Okay, you can directly use your scientific calculator, okay, using the binomial CD. For example, if the probability of Z, okay, not necessarily if Z, then the mean, the sigma is 1, mu is 0. Then if greater, okay, 0.7, this will be lower bound, upper bound is a very big number, okay, then sigma is 1, the mu is 0. If less than, then this is a upper bound, lower bound is very small number, okay, and then sigma is 1, mu is 0. Okay, if like this, this is a lower bound, this is the upper bound. Okay, if you got the X, okay, you got the case of given the X, okay, X like this, okay, this is a binomial, okay, can be approximated to the normal with some character. So this is lower bound, this is the upper bound. In this case, the mu n times p sigma is the square root of npq. So with this, thank you for your attention.